Okay, so we talked about strict domination, strict dominant strategy solution concept, dominant strategy solution concept. We talked about Pareto efficiency. And we saw that, strictly dominant or dominant strategy solutions need not be Pareto efficient, which is not good news. So when agents, individuals act selfishly, rationally, they might end up at a situation which is not socially very good, socially very desirable, in the sense that, again, what do we mean by socially very desirable? In the sense that there is another outcome, another strategy profile which induces an outcome which doesn't hurt anybody in the society, in the group, among the players, but it benefits at least one individual. Okay, so that's not something, that's not good news, but that's a fact. That's what we have. Okay, so I'll go back to strict dominant and dominant strategy solutions. So finding strictly dominant strategies or dominant strategies for individuals using the direct definition is not much fun. Let me give you a fast example. Let's keep it simple. I'll just make up the numbers. So looking at this, I see that there's two players. Player one has, since there is 3 rows, I conclude that player one has 3 strategies. Since there's 3 columns, I conclude that player 2 has 3 strategies labeled L, C, and R. So let me add a numeric representation of the preferences. So and for player 2, let me add those 2. Okay. So if we want to find strictly dominant strategies for player 1, well, what do I have to do? I have to check each strategy. So I pick strategy T, and check if it dominates every other strategy. That is, check if T dominates M, check if T dominates B. If T dominates N and B, I'm done. I will conclude that T is a dominant strategy, and since we know that each player can have at most one dominant strategy, I don't have to check for anything else. Okay? But if T doesn't dominate M or B, then I'll check if M dominates T, if M dominates B, and if it does, we're done. We'll conclude that player 1 has a dominant strategy. We know that it's exactly 1, and that's M. If that's not the case, then I'll do the same check for B. So it's not much fun. So when I look, for example, does T dominate M? Well, if player 2 plays L, player 1 is indifferent between them. So T cannot strictly dominate M, but it still can dominate. So I check if player 2 plays C, is playing T better than M? No, it's not. So T cannot dominate M, so I don't have to continue with T. I automatically know that T is not a dominant strategy. So I check with M. Well, I have to check because, the fact that T does not dominate M doesn't imply that M dominates T. I still have to check. So if player 1 knew that player 2 was playing L, is playing M at least as good playing T? Yes, but is indifferent. So again, this means that M cannot strictly dominate T, but it still might dominate T. So equally good, better. If player 1 knew that player 2 is playing C, playing M is better than playing T because 2 is bigger than 0. If player 1 knew that player 2 was playing R, playing M is at least as good as playing T. So playing M is never worse, but sometimes better, which means that M dominates T. Okay, so passed one test. Now I have to check if M dominates B. Well, I'm going to go fast, better, equally good, equally good. So no matter what the other player does, playing M is never worse than playing B, but sometimes better, which means that M dominates B, which means that player one has a dominant strategy in this game, which is M. Since we know that it's single, I don't have to check whether B dominates the rest. It can't. Okay, so we're done. Okay. But as you see, it's not much fun. And if the game was larger, there would be more pairs that I should check with. So that's not much fun. So what we'd like to do is we'd like to find a method, devise a method, which will help us finding dominant strategies, strictly dominant strategies of the players. Okay. And that's what we call, the tool that we're going to use is called the best response correspondence. You see, what we did when we were looking at this is we asked if player one knew what player two was going to do, okay, is M better than playing, is M better than T, is M better than B, okay? So is M better than all the other strategies? That is M a best response, best reply to L? And then we did that for C, and we did that with L. So that's what we're going to use. We're going to define a function, best response correspondence, so we're going to formalize that idea of player, of agent player I. Well, what does this do? So I'll denote it with BI, B for best, I for age player I. What does that do? It takes the strategy profile of the other agents as given. Okay, so what did we do? We said if player one knew that player two was playing L, if player one knew that player two was playing C. So it's like if player I knew what his opponents were doing, what would he do? So this maps every strategy profile of the opponents to a set of strategies of player I. I'm abusing, we usually use this notation for functions. Okay? So when I say correspondence, a correspondence is a set-valued function. So I'm going to note like that, but add the word correspondence. So what we have is for every strategy profile of the opponents, BI of S minus I, okay, is a subset of SI. It's not an element of SI, it's a subset of SI. And how is it defined? Well, it's defined as follows. It's the set of strategies of agent I such that playing SI is at least as good as playing any other strategy. That is, it's the best response to the strategy profile of his or her opponents. Actually, let me write it over here so we have more space. Let me shift this. So for any S minus I, is the set of strategies of player I, such that for any SI prime in SI. So what was the idea? He knows that his opponents are playing the strategy profile S minus I prime. He has to choose between SI and SI prime. So what we say is playing SI is at least as good as playing SI prime, given that his opponents are playing S minus I. Okay? So if you're using preferences, we can write it like this. if you're using numerical representations, we can write it like that. Okay? So far, so good? So far, so good? Okay. So the nice thing about numerical representations, by the way, well, let me continue with this. Let's say that we're using the numerical representation. In that case, it's, what does that say? SI, so given the strategy profiles of the other of the opponents of agent I, playing SI gives a utility, gives a payoff, which is greater or equal to the payoff that he would have obtained by playing any strategy, any other strategy, okay? Which is the same as saying SI is a maximizer of the function UI given the strategy profile of the opponents. Now this is nice because suddenly a problem of game theory turns into a problem of optimization. And you know, if the numeric representation is continuous differentiable, if it's differentiable, then life would become easier because we have a lot of tools from calculus which enables us to solve maximization problems, okay? So finding best response is actually nothing but solving a maximization problem, okay? So far, so good? So for example, in this case, B1 of L, the best response of player 1 to the strategy L of player 2 of his opponents, there's only one opponent, is T, M. I look at what point is the numerical representation, the payoff of player 1 maximized. It's 1, 1, 0, so it's maximized at T and M. B1 of C is, so 0 to 2, it's maximized, the maximum value that it can take is 2, and it's maximized at MB. B1 of R, 1, 1, 1. The maximum value is 1. And the numeric representation attains the maximum value at any strategy. Okay. Similarly, what is B2 of T? So we look. What is the best response of player 2 to the strategy T of player 1? Well, if player 1 plays T, the payoffs that player 2 can get is 1, 0, and 1. The maximum value is 1, and the maximum value is attained at L and R. I will not write the rest. It's a simple exercise, okay? So far, so good? Yes, sir?
How can we formulate this into a maximization problem, so a differential equation problem?
So here, well, because things are discrete, I can't use the techniques of calculus. There's nothing, but it's still a maximization problem. I'm trying to find the values. So when player 1 is trying to find his best response to L, he's restricting himself to this set and asks, what is the maximum payoff that I can get? The maximum payoff that he can get is 1. At which strategies do I get that maximum payoff given that my opponent is playing L? It's at T and M, okay? So not every maximization problem involves taking derivatives and so on, okay? So far, so good? So far, so good? So what is the question we should ask now? Is there always a best response and so on? But again, why did we introduce this tool? To find, well, our purpose was not to find dominant or strictly dominant strategies. So what we have to ask ourselves is, what is the relation between the best responses and dominant strategies? Okay, yes, sir. It's the intersection of all the sets. So, well, that's a guess. So your claim is for any game gamma, should we, tell me your preference, numeric representation or preferences directly? Numeric representation, so let me put UI, okay, for any player I in N, okay, for any SI star of player I. Your claim is the following: di star of gamma is equal to SI star. Okay, so player I has a dominant strategy and it's equal to SI star if and only if, what was the claim?
SI is the best response of all the other strategies.
SI star is the best response to every strategy of the other players. So that's in English. So let's write that in Mattish. Well, I can write it in two steps. So SI star is a best response to the strategy S profile of the opponents. And for which strategies? By the way, don't write it yet. Maybe what we're writing is not correct. Your guess, your friend, well, if you trust him that he will give the right answer, then you should. But we don't know. You see, when you're doing research, when you're doing science, you make a guess, you work on it. Sometimes you're wrong, sometimes you're right. So you should not rush. So this is true for, and that's your claim, right? Okay, everybody agree? Everybody agree? Yes, sir.
It would be true if you add another condition that it should be like only one, like the intersection.
Okay, by the way, we didn't write this as an intersection, but actually we could have wrote it as an intersection, which would make simple. So if SI star is in the best response of agent I for any strategy profile of the opponents, this would be also, another way to write this is SI star is an element of the intersection of all these sets where S minus I runs over all strategy profiles of the opponents. Those are the same thing, right? This is a bit more compact maybe. So that's what your friend claimed, but you claim more than this. You're claiming that it's the only one, right? Did I get it right? So this is what you're claiming. Okay, so which one? The first?
We can have two dominant strategies.
Sorry?
We can have two dominant strategies.
Can we have two dominant strategies?
Yes. For example, if we had
So let me remind you the definition. So SI star was the dominant strategy of player I in the game gamma, if and only if it dominated every other strategy. So no matter which other strategy you took, no matter which other strategy, I put a star here and get rid of the prime here. No matter which other strategy of player I you took, SI star would dominate it. So what did domination mean? Domination meant no matter what the opponents are doing. By the way, you see I'm speaking in English, but at the same time translating it to Mattish. So make a habit of this. No matter what the opponents are doing, SI star, given that he knows what the opponents are doing, playing Si star should not be worse than playing Si. Right? That's what it means. But that was not enough. We had one more condition, right? And there is at least one strategy profile of the opponents such that when the opponents play this strategy profile, playing Si star is better than playing Si. Okay. Actually, because of this condition, the domination relation is a symmetric relation. Okay? So that is, if Si star dominates Si, Si cannot dominate Si star. Because of this, there can be at most one dominant strategy. Yes, ma'am.
What if there are three things that the player can play? And two of them give the same results, and one of them is worse than both of them.
So you don't mean something like this.
No. Let's
So-
say, T is the same to, yeah.
Okay, so in this case, does M dominate T? No. Okay, so actually I can say that M weakly dominates T, but we're not going to get into this. So here, if this is the case, M does not dominate T. Neither does T dominate M. Okay, so for domination, it should be never worse, but in at least one strategy profile of the opponents, M should be better than T. Playing M should be better than playing T. Okay? That's not the case. So here, if in this game, player 1 does not have a dominant strategy. Okay? So far, so good? Okay. So, back to business. So, which one? The second one. Okay, everybody agree with that? By the way, let's do a fast proof of this. Let me shift things just for the fun of it, so you get a habit of doing proofs also. So that's what we claim. So take any game, take any agent, take any Si star and Si. So the set which contains Si star is the set of dominant strategies of player I. If and only if, what? Well, by definition, this is by definition, if and only if, for any Si, so I'm just going to write what we have there. Different than Si star, we have the following: for all S minus I in capital S minus I, Ui of Si, S minus I is greater than S star, Si S minus I. And there exists a S minus I such that Ui of Si star, S minus I is greater than Ui of. Okay. So, just by definition, we know this. So the next step, what to do? Well, if I want to relate this statement to best responses, remember the definition of best response, which I have erased, but let me write it in any case. So what was the definition of a best response? It's the set of all Si in capital Si such that, well, let me use stars here now, such that for any Si that was the, so what I want to do is, I want to relate this statement to this statement because I want to find the relation between dominant strategies and best responses, okay? But when you look at it, the quantifier on SI is just in front of the statement about UI. So what I have to do is, I have to move this statement up here, okay? Well, the first thing I'll do is I'll use the distributive property. So this is the case if and only if for any SI and SI minus capital SI, and for any S minus I, UI of SI star S minus I is greater or equal to UI SI S minus I. So that's one statement. And for any SI and S, right? Just simple logic. Okay, just distributed this. So the next thing I will do is, let me be a little lazy and do it on this. These are universal quantifiers, so we can swap, change the order of the universal quantifiers, right? So what I can do is change the order here. So this becomes for every S minus I in capital S minus I, for every SI in SI minus SI star. Okay? Can I change the order here? That I can't do. You can't change the order of a universal and an existential quantifier. So I'm stuck here. Okay? But let's work with what we have. So what does this say? For every strategy profile of the opponents, this statement is true. But what does that statement say? Well, it's exactly the definition of the best response. The only thing is, we just removed SI star. But if you put SI star, you get equality, so there's nothing lost. So the first part actually says, for any S minus I in capital S minus I, SI star is a best response of agent I to S minus I. And this statement. Okay? So, what does this statement say? Actually, let me write it down. I shouldn't be lazy. What does this statement say about best responses? Again, why do I want best responses? I want to relate dominant strategies to best responses. That's why I'm trying to translate everything to best responses. What does that say about best response of player I? Sorry? So from this statement, how do you make that conclusion? From this statement, let's just concentrate on this statement. One at a time. Okay? So initially, we concentrated on this statement. That's what we have. Now let's just concentrate on this one. What does that say?
And whatever strategy that is not SI star, it's not in the best.
Okay, so exactly. What your friend said is, any strategy than SI star is not a best response. That's what it says, because there's something better than that. It's not a best response to what? To some strategy of the opponents. So what that implies is, okay, what this implies is that for every SI in SI minus SI star, there exists a strategy of the opponents such that SI is not a best response of agent I to S minus I. Okay. Now, by the way, I didn't say that, but when you're writing these things, you have to be careful. So this implies this implies that. So we have this direction of the implication. Do we have it reversed? Well, again, this and this is the same. This and this is the same. So actually, this is an if and only if statement. You have to be careful when you're writing these things, okay? So what does this statement imply? Well, if SI star is in all the best responses, then SI star is in the intersection of the best responses, right? That's what it says. And what does this say? Okay, so if every SI, for every SI, if there is a strategy profile of the opponents such that SI is not a best response to that, it means that for every SI in capital SI minus SI star, SI is not in the intersection of the best responses. Right? Again, this is an if and only if. This is equivalent to this statement. This is equivalent to this statement. So it's a if and only if statement. Okay? So what does this say? SI star is in the intersection of all the best responses, but nothing else is in the intersection. So what does that imply? What does that imply? It implies that SI star is the only element in the intersection of the best responses. Actually, again, this is an if and only if. If it's the only element in intersection, it means that SI is in the intersection and nothing else is in the intersection. So again, this is an if and only if statement. So we started with SI, the set which contains SI star being equal to the set of dominant strategies of player I, if and only if, if and only if, if and only if, if and only if, if and only if. So what we have is, I'll write it short way, drop the quantifiers and so on. That's it. So it says, just look at the intersections. If there is a single element in the intersection, that is the dominant strategy. If the intersection is empty, there's no dominant strategy. If the intersection does not contain a single element, which means that this statement is false, this statement will also be false. So there will be no dominant strategy. Okay? By the way, let's apply that here. So let's apply that here. So for that example, intersection of S2 and S2, B1 of S2 is actually equal to B1 of L intersection B1 of C intersection B1 of R. So it's the intersection of this set and this set and this set. And when we take the intersection, there's only one element in the intersection. That's equal to M. Because M is the only element in the intersection, M is the dominant strategy of player one in that game. So far, so good? Any questions? Yes, sir.
Let's say there's a SI that satisfies the first condition.
Mm-hmm.
And in the second condition, it's that SI is not one of the SIs that satisfy the second condition. So how can we say that SI star is the one in that?
Well, you see,
How did we come up with that? There's only one.
Okay, so you see, this statement says that SI star is always a best response. this statement, that's what we used to show that it's the only best response. This shows that take any other strategy of player I. There is a strategy of the opponents for which SI is not a best response. So we didn't say that SI star is a best response. Actually, looking at the statement, I cannot conclude that SI star is a best response. All I can conclude that is SI, if I just look at this red statement, all I can conclude that is playing SI star is better than playing SI when the opponents play S minus I. From this, I do not know whether SI star is a best response or not. Okay, if I just had this, I could not conclude that SI star is the best response. But what I can conclude that is SI is not a best response. Okay, so SI star is in the intersection and nothing else, which means that the intersection only contains one element. So let's take a break, 10-minute break, and then after the break we'll continue. So if you want to turn in your homeworks, please do so during the break. Otherwise, you'll have to stop by my office sometime.